right, so video number 2 for chapter 2. When the bolus leaves the esophagus, what a boring way to start a lecture. When that bolus so you've chewed up your food, you've provided a little bit of enzymes to it, but the really key thing is you've made the food smaller and you've opened up the insides, and that's really important. That when that bolus comes down, it's going to hit a thing called a sphincter. And a sphincter is pretty much like an old camera shutter. It's on the top of the stomach. And once you get past that sphincter, you're now committed, because inside the stomach is a strange environment. It has the acidity, so it's very acidic. There's two major kind of cells in the stomach. There's cells that make mucus, which is kind of a sticky substance that lines the wall of the stomach and protects it from what the other cells make, which is acid. And so what you end up seeing inside the stomach after you've eaten food is a whole bunch of gastric juice, which is extremely acidic. And the funny thing is that I don't think people realize the acid's not for breaking down carbohydrate. Actually, wood can survive battery acid pretty well. The acid's not designed for breaking down fat. Fat in the stomach will eventually float to the top. When the stomach does kind of like a mushy, like a cat on a bed kneading, it's, when they say cats are kneading a blanket, or you see someone on TV making bread and they're kneading the dough, that kind of squishing and pulling and squishing and pulling, that will separate all your watery stuff in your food from your fatty stuff. And the fat in your food will float to the top. So if you have an In-N-Out burger from In-N-Out, all the fat will float to the top, let's say, in 1 to 3 hours. So it's not going to be exposed to any stomach acid. What the acid is for is protein. Dietary protein is actually more delicate than you think. And when you dump it into stomach acid, think of protein, all the proteins you eat like balls of yarn, and they will uncoil. We call that denaturing. And it's really important because, A, you have to open those up to cut them. And B, if it's something naughty, bacterial, viral, a toxin, if you uncoil it, it's not naughty anymore. Whatever it was, it isn't. Denaturing is like taking a Lego toy and smashing it. When you eat egg, and if you would eat raw egg, you'd have all these BBs of raw egg. These little babies are amino acids. We'll talk about those in the protein chapter. They're basically the building block of proteins, like Legos. So if you swallow a Lego set protein, or a protein Lego set, when you expose it to stomach acid, it uncoils. And so later on, your body can chop all those little babies apart. If you take an egg and shake it hard enough, you will uncoil the protein. If you were to drop acid, lime juice, lemon juice, in East Asian culture, in India, when they make paneer, which is basically milk cheese, you just take regular milk and drop in some lime juice or some apple juice or some lemon juice, and all those milk proteins will uncoil, come together, and form a big chunk on the bottom. Like when milk goes bad, the bacteria in it produce acid, and that acid uncoils the milk. And those of you who drink milk and have ever been exposed to really bad milk, it's all kind of chunked at the bottom. That's basically cheese, okay? That's denaturing. It's extremely important. We need it to break down the proteins later, so you have to uncoil everything. You have to denature it. And B, you can go to a wedding or a family reunion, eat shady stuff, and not get sick, because it has to survive stomach acid. Now, you might say, well, hey, Professor, people still get sick from food. Yeah, because when you eat infected food, it has so much bacteria, you physically can't denature it all. But for most of the time when you're eating a decent amount of bacteria, it's all those bacterial proteins which would infect your body and cause harm will be denatured, okay? So once you uncoil it, you can chop it. Who's the chopper? So the stomach makes mucus to protect itself, stomach acid to break down food. Sorry about that. That's my timer. And an enzyme called pepsin. Pepsin's kind of like a chainsaw. And here's the funny thing about pepsin. It's so powerful we don't make pepsin. Stomach cells make pepsinogen. It's a chainsaw with a cover. And when the pepsinogen is dumped into the stomach cavity, that gastric cavity, and it's exposed to the acid that your body makes, the kind of regulator, if you will, gets disassociated, and it becomes pepsin. And pepsin's extremely powerful chopper. It will chop up all the protein that you ate, and if pepsin sees other pepsin, it will try to chop up other pepsins. It works in acidic conditions. And those of you who use meat tenderizers, those of you who make jerky at home, There's one really famous meat tenderizer you can buy on the grocery store shelf called Adolph's. And what Adolph's has in it is papaya extract. Papaya is not a human, so papaya doesn't have pepsin. What papaya has is papain, and papain is plant pepsin. So when you see people using meat tenderizer for tenderizing meat, what they're doing is they're dumping a plant equivalent of pepsin onto the meat, and all those little enzymes are chopping up the meat proteins and making a stiff meat into a more palatable, softer, chewable meat. So meat tenderizers are used a lot when they make beef jerky, so you don't rip your teeth off when you're eating jerky. Okay, so that's what happens in the stomach. Your fat will end up floating, so stomach acid has no effect. Carbohydrate is fairly resistant. Your minerals, well, they don't get killed by stomach acid. Vitamins are susceptible to acid, but they're pretty much going to survive most of the stomach acid. Stomach acid is primarily to break down, to denature, to uncoil proteins. They look like balls of yarn, they become uncoiled, and we chop them up with pepsin. There's another enzyme in the small intestine that kind of does more chopping, but pepsin works in the acidic environment. The stomach is acidic. So the next goal is to move this acidic mass called chyme, and we're going to move that into the small intestine. The question or the problem is that mass is super acidic. If you don't do something, you will basically cook your small intestine. Like shrimp with lime juice. You would make a ceviche out of your small intestine. So what do we do when this mass leaves the stomach with kind of partially digested food and it enters the small intestine? That's the next video.